In this lecture, let's look at this example. We want to sketch the following transcendental functions without using any graphical tool. The first one, part A, it is an exponential function. Let's first find out what type of transformations they are. So I see that in front of x, I have a scalar, 1.7. And when I multiply a constant to the x, that means I have a horizontal compression or expansion. It is greater than 1, that means I have a horizontal compression. So the first point, if y equals to e to the power of 1.7 times x, that means I have a horizontal compression by a factor of 1.7. Then I notice that there's a 3 in front of e. And what type of transformation is that? So if y equals 3 times e to the power of 1.7 times x, I multiply a constant outside of the exponential function, which means I have a vertical expansion or compression. The scalar 3 is greater than 1, that means I have a vertical expansion. Then I notice that there's a negative sign in front of 3. So the next step, if y equals negative 3 times e to the power of 1.7 times x, I'm adding a negative sign outside of the function. That means I have a reflection about the x-axis. And lastly, there is another constant 5 that is added to this function. So if y equals 5 minus 3 times e to the power of 1.7 times x, I'm adding a constant outside of the function, which means I have a vertical translation. And I'm adding positive 5, which means it is a vertical translation upward by 5 units. Now let's use this information to sketch the function. So the first point, we notice that there's a horizontal compression, but the function still passes through this point, 0 and 1. So a sketch of this function will look similar to the original exponential function. It will look like this. And the next step is we multiply a 3 in front of the function. So the function will be vertically expanded by a factor of 3. So now this point, 0 and 1, will now move to 0 and 3. So the function will be vertically expanded. And the next step, we add a negative sign in front. So it is a reflection above the x-axis. And we get to this sketch here. The function now passes through this point, 0 and negative 3. And the last step, we have a vertical translation by 5 units. So this point now moves to 0 and 2. So that is the final sketch of this function. And in part B, the function g of x, it equals to 1 over ln of x minus 2. Since the input to a ln function or log function has to be positive, if you remember its graph, its domain is from 0 to infinity, and we exclude the 0 because x equals to 0 is a vertical asymptote. And the input inside the ln function is x minus 2, which means the domain of this function, we need x is greater than 2. Furthermore, I need the denominator is non-zero. So I need ln of x minus 2 is non-zero. A ln function equals to 0 when the input equals to 1. So that means I need x minus 2 does not equal to 1. So x cannot be 3. So by combining these two information, the domain of this function, I need a x that is greater than 2 but does not equal to 3. So using the interval notation, domain would be from 2 to 3, both exclusive, then union from 3 to infinity. Then let's find type of transformations the function has. So first of all, let's start with y equals the denominator, ln of x minus 2. I have a minus 2 to the input. That means I have a horizontal translation to the right by 2 units. Then, to get to g of x, I want the reciprocal of this function, 1 over ln of x minus 2. Now let's use this two information to sketch the function. The first panel shows the original function, ln of x. It is the inverse of an exponential function, so it passes through the point 1 and 0. Now the first step is a horizontal translation to the right by 2 units. So now the vertical asymptote moves from x equals to 0 to x equals to 2. And now the function passes through this point, 3 and 0. Then, the next step is to get the reciprocal of this function. For x that is really close to 2, we have a negative infinity value, and 1 over infinity is close to 0. But since this is a vertical asymptote, so on this graph we have a hole that passes through 2 and 0. Then on this graph, the function increases until it reaches to 3 and 0. But 1 over 0 is an infinity value, and here the y values are negative, which means its reciprocal would go to negative infinity. So we have a vertical asymptote at x equals to 3. Then over here, we have positive y values, and its reciprocal will still be positive. First of all, it passes through 3 and 0, but 1 over 0 is infinity, and as x is increasing, the y values also increases. So its reciprocal would decreases. So we'll see this on the final graph. Around x is 3, we have positive infinity. Then it decreases as x increases. And the last function is 3 times secant of 2x. Let's first find the domain of this function. A secant function is a reciprocal of cosine function, so I can rewrite this function as 3 divided by cosine of 2x. So we have a cosine function in the denominator, and we can never have a 0 in the denominator. So its domain, we need cosine of 2x is non-zero. And a cosine function equals to 0 when the input is an odd multiple of pi over 2. For example, pi over 2, 3 pi over 2, 5 pi over 2. So we need 2x is not an odd multiple of pi over 2. Or we can express that as when x does not equal to 2n plus 1 times pi over 4. For n that is integer. Then let's find types of transformations the function has. The first type of transformation is a vertical expansion because we have a 3 that is multiplied outside of the function. So if y equals 3 times secant of x, we get a vertical expansion by a factor of 3. Then the next step is we multiply 2 to the input. So if y equals 3 times secant of 2x, we are multiplying a constant that is greater than 1 to the input. That means we have a horizontal compression by a factor of 2. Now let's use this information to sketch the function. The first graph shows the original secant function. It passes through 0 and 1, and it has vertical asymptote at pi over 2 and negative pi over 2. We multiply 3 outside of the function, so there's a vertical expansion. So now this point moves to 0 and 3, and we get to this graph. Then the next step, we multiply 2 to the input, so we have a horizontal compression by a factor of 2. So now the vertical asymptote moves from pi over 2 to 4 pi over 2, which is here. And this vertical asymptote, negative pi over 2, is now at negative pi over 4. And now we get to the final graph for the function. And that is the end of the lecture. Let's look at one last example for this section. In the next lecture, let's look at an example of inverse trigonometric function.